We are back with a level-to-level projectile video, and this one is about a special range equation. Why is it so special? Well, that's simple. It's only used for level-to-level projectiles, and you don't have to worry about breaking apart the velocity. Let's take a look at the equation. The equation is range, or the delta x, how far it goes horizontally, is the velocity squared, or how fast it's moving, not in the x or the y, just how fast it's moving, times the sine of doubling the angle of launch, divided by g. Now, how do you get to that equation? Well, you could ask me in class how you find it, and I could show you how it's derived, or you could look it up on the internet, or let's actually ask ourselves why we're looking at this equation in the first place. It's so special it can only be used for level to level. And that's because it allows us to see what happens with angle and range, how they're related. To do this, we're going to graph it on a graphing calculator, which means we plug in this equation. I picked 20 to be my initial velocity. I picked the angle of, well, x, because I want to see how it changes with angle, and y is my range. 9.8 is my gravity, and so let's actually graph this and see what happens. Once you graph it, you get something that looks a whole lot like a parabola. It turns out it's not really, but it does have a maximum value. What we're going to do is we're going to use a calculator to calculate that maximum value. So let's see, and I got to pick a left boundary, so I'm going to go over this way, a little bit to the left, enter, and I'm going to go to the right. I hummed to myself. It's okay. Enter, and let's pick the middle, right about there. And when I do that, I get 44.9999993. Now remember, this is the calculator's version of finding the maximum. And it's pretty much telling us that the maximum angle, the x value that you would achieve maximum range, the 40.816, would be, well, basically 45. What we just learned by graphing this is the maximum range is achieved at a 45 degree above horizontal. Here's why. Because you're getting the most out of your vertical velocity to get time to increase. And you're getting the most out of your horizontal velocity to get it to move sideways. That is where it happens at the most. I will warn you, this is not true for a non-level-to-level projectile. This is true for level-to-level projectiles. Now, the next thing we want to maybe ask is, what about other angles? To that, let's just use the same graph. Except what I'm going to do this time is I'm going to take a couple of values, and I know what I'm going to do with this, so bear with me. I'm going to find the value of, let's go with 20. And I get roughly 26.24. And then I'm going to do the same thing, except now I'm not using 20. I'm going to use 70. And I get 26.24. Now I'm going to do this again, except now I'm going to pick a different angle. I'm going to put, let's see, 1. And I'm going to put, let's say 30. 35.35. And again, I'm going to hit calculate 1, and this time I'm going to put 60. 35.35. Why in the world am I getting the same result for different angles? Now, it's a graph, and you can see that that should be the case, that basically two values of y for, well, I should say one value of y for two values of angle. The important point is this. They always have to add up to be equal to 90. Okay? That means they have to be complementary angles to achieve the same range. Now, here's why. The faster it is launched sideways, it's not going to go up in the air very much. So a small angle will produce a really fast-moving object that doesn't stay in the air very long, whereas a really high velocity in the upward direction achieves a really large time, but it's not going very fast sideways. So the sweet spot is 45 degrees, but it turns out complementary angles, or angles that add up to 90, will have the same exact range. That's it for the special range equation. You can use the equation as long as it's only for level-to-level projectiles. You can try to memorize it, you can try to derive it whenever you want to, but again, it's kind of limited, so finding better solutions might be another alternative. So that's it for the level-to-level projectile equation videos. I will see you later.